So as we see in this illustration 1, there are 3 loops of the binomial model with strike price x of rupees 28 and rate of interest is 5. So if we notice, the high price and low price of each loop is 10% higher and 10% lower. So we will solve for probability only once. So let's get into the solution. So first loop has been taken, that is 30, and increase in price is 33, which is 10% higher, and decrease in price is 27, which is 10% lower. So let's calculate the probability of high price by using the formula CMP into 1 plus R raised to n minus low price upon high price minus low price. Here n is taken as half because in the question it is given that there are 2 sub period trees of 6 months. So we solve this and we get probability of high price as 0.6235. Now let's find the probability of low price by subtracting it from 1. So we will get 0.3765. So we solve these values for probability only once as the rate of increase decrease in all the loops are same. Let's solve for the first loop, which will be this one. 33 to high price 36.30 and low price 29.70. So step 1 will be calculating the value of options at high price and low price as shown in step number 1. So you get the value of high price as 8.3 and low price as 1.7. Now we will skip the next 2 steps as we have calculated probability only once. Then step 4 will be multiplying these values of high price and low price with the probabilities respectively found above. So the expected value of maturity will be 5.815, and then the final step will be to use this amount and divide it by the interest. So the value for node B will be 5.673. Now let's solve for another loop, that is 27, and rise in price is 29.70 and the decrease in price is 24.30. It is again 10%, hence we skip the probability part. So again you will calculate the value of option into probability by the formula given in step 1, and we will only exercise if the answer is positive. This will give you the expected value of maturity. Now we will discount it for 6 months by using the interest which is given, and then the value of call option at C will be 1.0341. This is step 5, that is the discounting part, which is not shown separately in steps like it was showed previously in detail. And now finally we solve the final loop by substituting the values of node B and node C in A. So now we will follow the same steps again, that is by putting the value of call option and multiplying it by their respective probabilities. Then again you will get the expected value of call at end of 6 months, and then you will discount it for 6 months, and then you get the value of call option today, that is rupees 3.83.